For the models, this chapter has concentrated on basic models. Here we shortly mention several model extensions that address issues ignored by the basic models and have received attention in economic theory. Risk aversion. All of our discussion in the Bayesian model assumed that players are risk neutral. Obtaining a utility of 2 with probability 1 over 2 is equivalent to obtaining a utility of 1 with probability 1. This is why we could just compute players' utilities by taking expectation. In reality, players are often risk averse, preferring a somewhat lower utilities if they are more certain. A significant body of work in economic theory deals with the formalizing and analyzing strategic behavior of such players. In our context, a particularly interesting observation is that the revenue equivalence principle fails, and that with risk-averse bidders, different mechanisms that implement the same social choice of function may have different revenue. As an example, it is known that first price auctions generate more revenue than second price auctions if the bidders are risk averse. Interdependent values. We have considered only independent private value models. The types of the players are chosen independently of each other, and each player's valuation depends only on his own private information. In a completely general setting, there would be some joint distribution over states of the world where such a state determines the valuations of all players. Players would not necessarily get as private information their own valuation, but rather each would get some signal, partial information about the state of the world that provides some information about his own valuation and some about the valuations of others. Most of the results in this chapter cease holding for general models with interdependent values. A case that is in the extreme opposite to the private value model is the common value model. In an auction of a single item under this model, we assume that the object in question has exactly the same value for all bidders. The problem is that none of them know exactly what this value is, and each player's signal only provides some partial information. An example is an auction for financial instruments, such as bonds. Their exact value is not completely known, as it depends on future interest rates, the probability of default, etc. What is clear, though, is that whatever value the bonds will turn out to have, it will be the same for everyone. In such settings, an auction reality serves as an information aggregation vehicle, reaching a joint estimate of the value by combining all players' signals. A common pitfall in such cases is the winner's curse. If each bidder eats their own estimate of the object's common value as determined from their own signal, then the winner will likely regret winning. The fact that a certain bidder won means that other signals implied a lower value, which likely means that the real value is lower than the estimate of the winner. Thus, in equilibrium, bidders must bid an estimate that is also conditioned on the fact that they win. A commonly considered formalization that takes into account both a private value component and a common value component is that of affiliated signals. Roughly speaking, in such models, each player gets a signal that is positively correlated. In a strong technical sense called affiliation, not only with his own value but also with the values of other players. In such settings, ascending English auctions are better, generate more revenue than the non-adaptive second price auction, which is equivalent to an English auction in private value models. As the bidding progresses, each bidder gets information from the other bidders that increases his estimate of his value. Complete information models. Our main point of view was that each player has its own private information. Some models consider a situation where all players have complete information about the game. It is only the mechanism designer who is lacking such information. A prototypical instance is that of King Solomon. Two women, each claiming that the baby is hers. The women both know who the real mother is, but not King Solomon. We must design a mechanism that elicits this information from their different preferences. Several notions of implementation in such setting exists, and in general mechanism design is much easier in this setting. In particular, many implementations without money are possible. Hidden actions. All of the theory of mechanism design attempts overcoming the problem that players have private information that is not known to the mechanism designer. In many settings, a different stumbling block occurs. Players may perform hidden actions that are not visible to the mechanism. This complementary difficulty to the private information difficulty has been widely studied in economics and has recently started to be considered in computer science settings.